Hello students, welcome to our today's class, and today we are going to learn a very interesting topic, a very easy topic of this chapter. So everyone pay attention and be ready with your notebook. Okay? Yes. So before moving to our today's topics, let's revise what we have learned in our last class. Okay, so which chapter we are learning? We are in the chapter number 6, that is refraction of light. Okay, so the very first topic which we have learned in our last class is mirage. What is mirage? So here you can see this rays. You can see one tree is there above the hot surface and one tree is there below the hot surface. So here you have to imagine that you are standing over here, okay, and when you look towards the hot surface here, when you look over here below the hot surface, you will see an image of plant, but in actual the plant is not here, plant is over here. Okay, so why this thing happens, let's see. The refractive index of air keeps increasing as we go to increasing height, you all know that. Okay, yes, so the light rays coming from a distant object appear to be coming from the image of the object inside the ground, which I have said earlier. So that is called as what? That is called as a mirage. We have learned this in detail in our last class. If you didn't watch our last class tutorial video, please go and watch it. Okay, so this is about a mirage. Then we have learned about the twinklings of star. What is twinkling of star? So here star appear to be a point source because of their being at a very large distance from us. So stars situated at a large distance from us. So the apparent position of star keeps changing a bit. Here the one person is standing, let's imagine. So when he look towards the star, he will see the star's position over here, but in real the star position is not situated over here, the star is not here, but the star is over here. This is the real position and apparent position of star, which means what? The position which we see, but that is not the real position of star. Okay, so the refractive index of air keeps changing continuously. Because of this change, the position and brightness of star keeps changing and star appear to be twinkling. Okay, we know that star twinkle, but do the planet twinkle? No, we do not see the twinkling of planets. This is because of what? The planets are much closer to us as compared to stars, and they therefore do not appear to be a point source, but they appear as a collection of point source. Okay, so this everything we have learned. Then we have seen that this is the earth. Above the earth there are so many layers like stratosphere, troposphere, you all know this. Okay, so when the person sees a sun, let's imagine this is the sun. Okay, so when he look towards the sun, he will see the position of sun to be here, but sun is not actually here, sun is over here. Okay, so this is the effect of atmospheric refraction. So till this we have learned everything in our last class. Okay, let me remind you about your assignments. Students, only regular students doing their assignment regularly. Let me tell you students, the assignments are not only for the regular student. Okay, assignments are for all students have to perform their assignments, all students have to submit their assignment. This is not only for the regular student, and the regular student, the student who are doing their assignments, very good, keep it up. But next time onwards I want 100% attendance of all the students. Okay, yes. So now we are going to see a very beautiful topic which is very easy, that is dispersion of light. Okay, before going to the to our topics, let me tell you one thing, that just fix these things in your mind, that dispersion. What is the meaning of this word dispersion? So the dispersion, which means separation, and it also means distribution. Okay, distribution of light. Okay, distribution of light into the different colors. Okay, so that we are going to see. Before moving, there is one activity which is very beautiful, and it is given in your textbook, that is, hold the plastic scale in your compass in front of your eyes and see through it while turning it slowly. I think many of you have did this in your childhood. Yes? If you're not did this, come on, go and do this. This is very easy and very funny. Okay. So when you will do this experiment, what you will get? You will get a spectrum like this. Yes? So you will see the light rays divided into different colors. Okay, these colors appear in the following order, that is violet. Here is a violet color, then indigo, then blue, green, yellow, orange and red. So these combined colors are colors we called as vapor. Okay, you all know that. Then light is a electromagnetic radiation. What is electromagnetic radiation? Here electromagnetic radiation, it is a kind of radiation which includes the different waves like radio wave, then gamma rays, X rays, in which electric and magnetic field vary simultaneously. Okay, then wavelength is an important property of radiation. What is wavelength? You have learned this in your last standard, that the wavelength, which means the different waves like a sound wave. Okay, and it is denoted as lambda. Okay, you know this. Then here, the wavelength of radiation to which our eyes are sensitive is between 400 nanometer and 700 nanometer. So 400 nanometer and 700 nanometer, it is here in between this our eyes are very sensitive. Okay, the radiation of different wavelength appear to have different colors. Yes, you can see over here, these are the different colors, they have the different wavelength. Okay, here remember these terms, that is, the red light has maximum wavelength. Here the very first light called as red light, this has maximum wavelength which is close to what? 700 nm, which means nanometer. Yes. Okay, and the violet light, here is a violet light, it has smallest wavelength which is close to 400 nanometer. This many times this will ask in your question in your exam, so do remember this. Okay, red light has maximum wavelength and violet light has the smallest wavelength. Okay, what is 1 nanometer is equal to? So 1 nanometer is equal to 10 raised to minus 9 meter. Okay, in vacuum the velocity of light rays of all the frequencies is the same. Okay, then the velocity of light in a medium depends on the frequency of light, and thus the different color travel with a different velocity. Here you can see the different colors. All these colors have the different velocity. They travel with a different velocity. Okay. Yes. So here there is one experiment that is given. This is called as dispersion of light. So what is that? It is very easy. Let's see. When when the white light enters a single medium like glass, sunlight always has a white light. Okay, we see the sunlight is in different colors, but in actual the sun has white light. So when the white light enters a single medium, here the white light enters into the medium that is called as glass prism. Okay, the angles of refraction are different for different colors. Here you can see the different colors in Vibgyor order. Okay, so the angle of refraction are different for these different colors. Okay, so when the white light coming from the sun through air here the white light it coming from the sun through air. Here everywhere is air. So when the white light coming from the sun through air enters any refracting medium, here the refracting medium is what? Glass prism. Okay, yes, so air is a rarer medium and glass is a denser medium. So the light comes from rarer to the denser medium. It emerges as a spectrum of 7 colors. Okay, spectrum, which means what? A bunch of different colors. So what it will get? It will get a different colors, 7 color spectrum. Okay, so, what is dispersion of light? Dispersion of light is the process of separation of light into its component. Here, there is only one light, but it gets separated into the different colors. Component colors, which means what? Are different colors while passing through a medium. Which medium is there? Glass medium, that is a denser medium, is called as dispersion of light. Okay, easy? This is very easy. So, who discovered this term? Yes, Sir Isaac Newton was the first person to use a glass prism to obtain sun spectrum. So, Isaac Newton discovered this sun spectrum. Here what he says, when the white light is incident on the prism, different colors bend through different angles. As I have told, when the white light, that is sunlight, enters into the prism, the different colors bends. Okay, here you can see the bending of different colors which get a different angle. So the different colors bend through the different angles. Okay, among the 7 colors, red bent the least one. Here you can see the red light, first light, it bends at the smallest. Okay, least means small. Okay, while over here you can see the violet light, it bends the most. You can see the distance between the two lights. So the red light bent least and the violet light bent most. Okay, thus the 7 colors emerges along the different path and get separated, and we get a spectrum of 7 colors. Okay, basically the thing is that when the white light entered into the prism, it gets distributed into the 7 colors. That is called, Whip cure is called as what? Dispersion of light. Okay, easy, very easy. Now another easy topic which we are going to learn, that is a rainbow production. I think many of you have already seen a rainbow till now. Once you have seen this. I think yes, many of you have seen the rainbow. So rainbow is a beautiful natural phenomenon, right? Yes. So it is a combined effect of number of natural processes. When the number of natural processes combine with each other, what they form? They form a beautiful rainbow. Okay. It is a combined effect of dispersion, refraction and total internal reflection of light. What is that? That we are going to see next, but just remember this, that it is combined effect of what? Dispersion, refraction and total internal reflection of light. Okay, it can be seen when? Mainly after a rainfall. So after a rainfall we will see a rainbow. Okay, so how it get produced? Let's see. So here we have taken a small droplets of water which act as a prisms. Everyone know about the term prism. This we have you have seen maybe in your laboratory. Okay, so small droplets of water act as a small prism. Okay, so what happened over here, when a light ray from sun enter this droplet, here the light ray it gets enter to this droplet, it gets refracted and dispersed. Okay, it gets refracted. Here you can see the bending. Refraction means, always remember, bending. So when the light ray enters into the droplet, it gets refracted. You can see over here this bending, and it gets dispersed. That means what? The light gets separated, it gets distributed into the different colors. Okay, then there is internal reflection takes place. Okay, what is that? First, remember that when the light gets entered into the droplet, it gets refracted into the different colors. Let's imagine that this color is a red color. Okay, let's imagine. And this color is a violet color. So over here you can see the bending, that means a refraction. But there is internal reflection takes place. What is that? The reflection means what? A ray which bounces back within the same medium. Here these two rays, they are bounces back within the same medium. Here you can see, okay, the ray coming over here and it get bounces back within the same medium. Okay, so their internal reflection takes place. Yes. Then, and after that, once again light gets refracted while coming out of the droplet. So here it, their internal reflection takes place, and again you can see over here it gets reflected, it gets refracted. Okay, not reflected, it gets refracted while coming out of the droplet. You can see over here this bending. So what happened when a light ray fall on the droplet, it gets distributed into the different colors. Let's imagine this is a red color and this is a violet color. Okay, then here they get refracted and here their internal reflection takes place, and after that again they get refracted while coming out of the droplet. So these all processes together will produce a beautiful rainbow. So this is the processes which are very used, which are very important to produce a rainbow. Okay, so this is all about today. We have learned what we have learned today: dispersion of light and a rainbow formation. The two terms, these two terms are very easy. Watch the tutorial video again, you will definitely understand this. Okay, and do your assignment on time. Thank you.